Trapezoid, rhombus. These two are not on the formula sheet. You're responsible. So far, here's what you're responsible for. Population density formula, trapezoid, rhombus. All the others are on the formula sheet. So let's go over review. I gave it to you yesterday, but we didn't use it at all. Area of a trapezoid. 1/2 its height. We talked yesterday, height's the same as altitude. Coming from a vertice, makes a right angle on the opposite side. And then I multiply that with the two bases added together. A trapezoid has two parallel sides, which are called the bases. Two parallel sides, which are your bases. That's what B1 and B2 are, your bases. And then rhombus, that was 1/2 D1 times D2. And we went over this yesterday. D stands for its diagonal length. Bless you. Bless you. No? Don't have it in you? Dig deep. Dig deep, Charlie. Come on, dig deep. Nothing? Okay. 3 still pretty impressive, though. I'll take that going into the weekend. Rhombus properties. All right. I'm just not going to give you the two diagonals and you're good. Now you substitute them in and we're good to go. All right. You're going to have to work for those at least one diagonal length you're going to have to work for. So let's go over the couple properties of a rhombus that are going to be pretty important. First of all, diagonals are not congruent. All right, just because you know one, that doesn't mean it's congruent to the other. That's a rectangle, not a rhombus. Anything you remember about a rhombus? Let's go, dig deep now. Your quad unit. I know I wasn't here for that one, but what do you got?
Sides.
All sides congruent. That'll help, yep. If I know one side, I know them all. Actually, there's probably... I'm really focused on the diagonals here because that's what the area formula needs. Anybody remember special properties of diagonals? Go ahead, Kelsey. That's kite. But how about this? They bisect each other. Okay, that's it. You were thinking about a kite, but they bisect each other. Diagonals bisect each other. And there's one other big one about the diagonals. Nate Dogg? Perpendicular. Yep. Diagonals form right angles. They're perpendicular. Now, there's more properties, but these are the 3 that'll get you through the area unit. Diagonals are perpendicular. Okay, ready to roll? Okay, let's see how many we can get through here. One diagonal measures 6 feet. The area is 48. What's the measure of the other one? So just something basic so I can get you guys start using the area formula. 1/2 D1 times D2. All right, you let me know. Where do you want the 6 to go and where do you want the 48 to go? One diagonal 6 feet. The area is 48. Where do you want me to put them here? 10. Where's the 6 going? Or 2, right? Doesn't matter. 1/2, 6. And how about the 48? Yep. And we're solving for the other diagonal. And remember, that's all multiplication there. Right? 48, 1/2 of 6 is 3 times x. And how long is that other diagonal? When you're ready, 6? 16, yep. 16, what do we got here? Feet. Okay, we're all right there. A little basic one. All right, now here's one where we're going to have to apply the properties. Find the area. So I first say, all right, area, it's a rhombus. Let me just at least get the formula down. 1/2 D1 D2. All right, so I need both diagonal lengths. One diagonal length you should get right away if you know our properties. Go back to the properties. All sides congruent. Diagonals bisect each other. So right away, can you get me one diagonal length? And then I'll work with you on the other one. What's one diagonal length right away? 8? 80. Why? Diagonals bisect each other. So if this is 40, darn right, the other piece is 40. So one diagonal is 80. Now we got to work together on the other one. And I can see some of you guys see where this is going. Diagonals are perpendicular, so they form a right angle. Everyone sees that right triangle. If that was 40, we just said this is 40. And now I can do Pythagorean theorem on one of the 4 right triangles inside the rhombus to find a part of the diameter. So here we go. A squared plus b squared equals c squared. Can somebody plug in the 40 and 50 where they need to go into Pythag? 13, plug them in for me.
40 squared.
Yep.
Plus b squared.
Good. Perfect. I want to make sure you guys understand the 50 is the hypotenuse here. What is that b value when you have it? 7 b value? 30. But be disciplined, right? That's not the length of the whole diagonal. It's only half of it because it's getting bisected. Double it, and now I'm plugging in 60. So the area of this rhombus, 2,400. If you're putting units on, just make sure it's square units. Okay. Rhombus good. We can move on to a little, I think, trapezoid. Yep. Look at those directions. You guys got off easy yesterday with nearest 10th. Now we're going simplest radical form. Leave it in radical form. All right. Trapezoid, not on the formula sheet. That's my responsibility. 1/2 the height, B1 plus B2. All right, does everyone, I gave you the bases. 6 and 11 are the bases. Again, bases mean the parallel sides of the trapezoid, which are AB and DC. So in for B1, 6, B2, 11. I just need your help finding the height of this trapezoid now. Finding the height. All right, we have to draw the height in. All right, the height's not, remember, height comes from a vertice perpendicular to the opposite side. So from, there you go, from vertice B, let's draw the height in. We know it forms a right angle. So I need your help finding that height. And we went through these yesterday. Here's my 45, 45, 90. All right, I need your help. Can somebody help me get a side length in that 45, 45, 90? Because I got the 6 here. I got the whole, remember, 11 is DC. Can you get me a side length on that 45, 45, 90? Any side of that 45, 45, 90. How can I use what I already know to get to a side length there? And then we'll get to the height. 12, can you get me to a side length?
Well, you can do.
Go ahead. Yeah.
6 minus 11.
Okay. How do we get there? If that's 6, opposite side, 6. Opposite side's congruent. I formed a rectangle here. And if the whole thing was 11, if that was 6, that's got to be 5. All right, we're getting there. We said that this was a 45, 45, 90 triangle yesterday, because I don't want to review the rules again. Yesterday, what did you know about the two legs of a 45, 45, 90? 6, what do we know about the two legs? Yep. So if one leg is 5 across from the other 45 is 5. Are we okay on how we got to that height? This is why it's a little bit tougher than you think. Just memorizing a formula won't just cut it. And I would just plug it all in your calculator. 42 and a half. Look, oh, no, yeah, 42 and a half. I got thrown off by simplest radical form, but there's not any radicals in there, so it doesn't need it there. All right, ready? Everyone okay there? Before I go on to the 30, 60, 90. You see what's coming up. Good. I see some of you guys drawing your heights in already for number 2, for letter B. Go ahead, draw your height in. Excuse me. All right, let's see here. Doing the method Rachel told us in part A, if that's 7, this is 7. So this piece has to be 4. All right, is 4 the shorter leg, longer leg, or the hypotenuse in that 30, 60, 90? Think about it. Is the 4 the shorter, longer, or the hypotenuse here? 6 again? Or is it, what angle is it across from, Nate? 30, so that makes it the longer is across from the bigger angle. Right? This is across from the 30, which is the smallest angle, so that makes it the shortest side. How do I go from 4 to the longer side? If you got to flip through and remember the rules from yesterday, how do I find the longer leg in a 30, 60, 90 triangle? How do I find the longer leg? 12? Longer leg equals shorter leg. There you go. Radical times radical 3. So shorter leg times radical 3. So what would be my longer leg here then? What's the length of your longer leg? 1, Anna? 4 radical 3. Yep, so there's your height. 4 radical 3. Are we okay there? All right, let me show you now, because it doesn't do you any good just plugging it all in your calculator and getting that decimal, because I want simplest radical form. So here you go. I'll help you out here with the algebra. 1/2 4 radical 3 times 18. Right? I could do 7 plus 11. All right, let's keep going here. I can multiply everything except the radical 3. So leave the radical 3 in your answer. 1/2 times 4 times 18. You can multiply all the numbers. It's just I can't multiply the radical at all. So 1/2 times 4 times 18. And leave your radical 3 there. And what are we getting there? 36. Radical 3. Take a look. That was a little bit of a tougher one. You got to remember your 30, 60, 90 rules. And then are you okay on how I went from this step? I can't multiply anything times radical 3 unless it's another radical, which I don't have. So I multiplied the numbers. Is this it here? Ooh, that bad boy. All righty. Amelia and her pennant. The E team, everyone. The E team. Aaron, Amelia, and Elena. All good. I was just going through my head. We don't have any E's in here to add to the E team. All right. What's the area of her team's pennant? Well, what shape is her team's pennant? That's a trapezoid, right? All right, so let's get the formula down. Oh, I didn't even know it. The team with the edge. Edge, E. There you go. Yep. Those kids, crazy kids. Is there anything on this diagram that's already given to you that I can put into my formula? Let's start there. The less I have to find, the better. Is there anything on here that I can plug into my formula? 13, Charlie, anything I can plug in?
If you draw in the height,
Yep.
it forms a rectangle, so the height would be 4.
Perfect. If you don't see this, that it's perpendicular to the opposite side, what Charlie just said is great. Draw your height in, and you'll be like, oh, wait a second. If that's the height, that matches that number, so the height's got to be 4. Perfect. So the height's 4. Anything else I can plug in my formula? I think I gave you something else there too that you could plug into the formula. Anything else? 4? 10 is a base. All right, so look, the only thing we're missing, and let me do a different color here. The only thing I need your help with is how long is that base, right? How long is that base? Because that's the missing value I need. Oh boy. All right, let me go back to that height that Charlie was talking about. Let me draw that, and we know that's a length of 4, right, everyone? That's a length of 4. Still trying to find that yellow piece. And again, hey, keep in mind here while we're talking, 10 is the whole thing, right? 10 was the whole thing. Let's not forget that, because now when I draw that in, it looks like 10's this piece, which it's not. And I don't want to give this away. Let me give you one more piece. This is the base we're trying to find. Isn't that congruent to that base right there too, right? Because that's a rectangle. Any thoughts here? I don't want to give this away. Remember, if you find this, it's the same thing as the base we're looking for. So can I find that somehow maybe? I drew in that height of 4. Come on, I don't want to give you anything else. Look what I got there. What's up, Nate Dog?
Did you do like Pythag to find what's like?
That's all you needed to say. Ready? Look at everyone see a right triangle there? I have 2 sides. How about finding that side using Pythag and then subtracting it from 10, and you got the side I need. Everyone, good plan, Nate, good plan. All right, so I'm going to do Pythag. And I'll say 4 squared plus b squared equals hypotenuse 8.5 squared. When you have that value, let me know. Anna, when you're ready, what's that missing side of the right triangle when you're ready? 7.5. All right, we already talked. That's not the one I was looking for. I'm looking for 10 minus that. That'll give me the other base. So 2.5. A little challenge. All right, got those calculators for this last one here. Does yours say perimeter and area? Okay, good deal. Let's do area first. I should have wrote in, this is a parallelogram. All right, this is a parallelogram. Area formula for a parallelogram from yesterday. 1, Anna, area formula for a parallelogram.
Area equals base times height.
Yep, base times height. Remember, that's one on your reference sheet. Don't have to remember. We talked yesterday. Height is drawn from a vertice perpendicular. So this is your height right here, which I don't have. Meaning, what's the base then? Height always drawn to the base. What's the base of this parallelogram? 4, base? 12, good. So it's going to be 12 times something. What we have done is that triangle was always 30, 60, or 45, 45. We would use our rules and find the height. But now it's not. I got a 35 in there. It is not one of my special right triangles. It is not. I cannot apply any of the rules. So where do I go from here? You guys know. We just got to dig a little deeper here to figure it out. All right, everyone good. It's not 30, 60, or 45, 45. Can't use the rules. But it is a right triangle. I can't use Pythag. I don't have enough information. What am I left with then? Oh, is he going to do it? Is he going to say it?
SOHCAHTOA.
Yeah, let's go! Darn right. We're going to SOHCAHTOA. All right, that's what you need. All right, don't have 30, 60, 45, 45. Can't use Pythag, but it is a right triangle, so I can use SOHCAHTOA. All right, let's review. Going from the 35, what's the 4? Opposite, adjacent, or hypotenuse? Is the 4 opposite, adjacent, or hypotenuse to the 35? 1, Anna? Opposite. What's my height? Adjacent or hypotenuse to the 35? 4? Is it adjacent to the 35 or the hypotenuse in that right triangle? Adjacent. What do I use with O and A? And don't tell me TOA. What's the darn T stand for? Don't tell me TOA. 10. Tangent. Thank you. Yep. But I do abbreviate it. Yes, tan. So here you go. Tangent of 35 equals opposite over adjacent. I remember how to solve these. Put it over 1, and let's cross multiply. Make sure you're, I don't know if you've let friends borrow your calculator, if you have any, but make sure the mode is in degree mode. You pick that one up, Charlie. Good. Make sure it's in degree mode. So hit your mode button. Make sure you're in degree mode. All right, so when I cross multiply, I get tangent of 35 times h equals 4. And then what are we doing on both sides here to get h by itself? 7? Divide by tan 35, yep. And you guys can do that right in your calculator. No rounding, right? No rounding. Plug that number in for your height. And then round to the nearest hundredth. No. 68.55. Questions? All right, I am going to leave. We're not done yet, right? Because we still have to go perimeter. It's a parallelogram, so you already know. And all I'm going to do is write the final answer up here. We already know we have 12 plus the opposite side's congruent, so 12. Now what you guys you're responsible for are those congruent sides. Okay, so now go back. How do I find this side now? You guys have a couple options, right? You already found the height, so you could do Pythag, right? You got the height already there, so you can do Pythag, or you can do with the 4 and that missing side, so opposite hypotenuse. It's up to you. So you got to find that side so you can add it to 12 and 12 again. So either use Pythag or sine or cosine, whatever you think is appropriate. I'm ending up with 37.95 at the end here. And please just don't write that down. Make sure we can get that. That missing side of the parallelogram, I'm getting about 6.9737. All right, I did sine of 35. If you chose to, if anybody used Pythag, make sure you use the non-rounded answer from your area there. All right, make sure you use the non-rounded answer when you found the height. All right, so whatever you guys got with 4 divided by tangent of 35, get that back on your calculator and plug all of that into Pythag if you guys are choosing to use Pythag. And if you're getting this, go ahead, let's get going. Let's not waste some time here, get a couple problems done before we get out of here.
Yeah.
Yep.
I
Anna, circle quiz 3. You alright with that problem, Spence? Okay, where? Probably it was in your calculator, you just figured it out. And the height was when we did 4 divided by tangent of 35. Right? Right there, there's your height. So how are you finding the sine pi bag or sine cosine tangent?
I have to do it today.
Pi bag,
What's
alright,
it
so it's
do?
gonna be this, your height squared, which was this, but I wanna use all of that value, not 5.7.
Oh, it's doing
So I'm gonna throw off your answer if you round that, right?
100%
So I wanna use that full calculus to display squared
I submitted today.
plus
Hoping that
4 squared, yep,
I'm only my choice.
equals that c squared,
What? Oh. This.
yep.
No, but it's like,
There's your
I
side,
looked it
yep,
up, I
there's
checked
the
the
side
bunch of
there.
calculators to see what they
No,
said.
not till the end, yep. You're gonna find the perimeter, you wanna add that to itself, 12 and 12.
Percent.
Right.
It's not a lot.
Correct, you got it.
17. How long? 17 a lot.
Not really, it's a 95 cosine, of course it's gonna be.
Well, that's my.
Good talk, let's get to the, good stories, let's get to the homework.
Let's see.
All right.
That's another. Yep, we're gonna share.
One, two, three. Some of mine is 4 problems, are you kidding me? Let's go. 5 problems? 19, 20, oh, I didn't see 26. 26, you got A. If anybody needs a slice of graph paper, because you got a graph for 26, make sure you take one before you leave. It's on top of the shelves over there. You need a slice, because you know you're gonna have to graph 26. No ghetto graphs either. Actual graph paper.
Yeah, like 2. So might be.
Wait, Nathan, you say you want some?
What's the formula again?
Let's get it done this weekend. Come on.
Thanks, man.